Ahoy there! Welcome to Oz Discovery. I'm Patchy the Pirate. Today we'll be focusing on pyrite. Not me, this pyrite. Today we will set sail into learning the composition and characteristics of pyrite, describing the influence of acid sulfide soils and the significance of this issue through analyzing supporting and contrasting evidence. Let's first start with fundamentals about pyrite. Pyrite has a physical appearance of brass yellow mineral with a bright metallic luster and has a chemical composition of iron sulfide and has many uses, including an ore for the production of sulfur and sulfuric acid, an ore of gold, and is occasionally used as a gemstone. Pyrite is the most abundant sulfide in the world, generally found in sedimentary rocks, particularly in limestones, carbonaceous siltstones or shales, and sandstones, but can also be found in igneous and metamorphic rocks. Much of iron pyrite in sediments is orthogenic, formed in the depositional environment, or early diagenetic, formed during the transformation of the sediment into a rock, a process known as lithification. This process requires the presence of organic matter within the sediment, sulfate solution in water pores, and an anaerobic reducing chemical environment, which is created due to the presence of decaying matter within the sediment. Pyrite seldom forms in freshwater environments, and pyrite crystal formation depends upon the iron content. Pyrite results from the action of bacteria, reducing sulfate ions dissolved in water pores to sulfide, and thus the presence of iron instigates the growth of iron sulfide crystals. Originally, the iron is derived from the weathering of older igneous and metamorphic rocks. Deep weather over prolonged periods of geologic time releases the iron, forming soluble iron salts. The dissolved iron solution then travels to the sea, where ferrous iron is oxidized and deposited, waiting to be chemically combined with sulfide to form pyrite. Pyrite, as mentioned, is detrimental to the environment and is exposed through mining and tailing. Subsurface mining is a progress generally below the water table, and thus water must be constantly pumped out of the mine to prevent flooding. When a mine is abandoned, the pumping stops and water floods the mine. This introduction of water instigates acid rock drainage situations. The outflow of acidic water from metal or coal mines. Metal mines potentially generate extreme acidic discharges where the ore is a sulfide mineral correlating with pyrite. Some mines establish acidic drainage within 2 to 5 years after the mining begins, whereas others are not detected for several decades or centuries, and thus for this reason acid mine drainage is considered a chronic long-term environmental concern. Tailings are the remaining or leftover material after the process of separating the valuable fraction from the worthless fraction of an ore or sediment, as these tailings contain large amounts of pyrite. When exposed to water and oxygen, these minerals will spontaneously oxidize, which will lead to acid mine drainage and further damage aquatic life that depend on clean water to survive. Aye, matey, now you know about pyrite. Now you must remember these notes or you will walk the plank. Well, that's all from Patchy the Pirate. Next you will be meeting some special guests who will explain the environmental impacts, analyze contrary evidence of the influence of pyrite, and the environmental mitigation regarding the chemical compound. Have fun!